How to create and save a new file in the Unix terminal. Repeat the same steps to create a file containing the Amazon dataset. I've already created and saved this dataset as test file. Use concatenate method to view the contents of the file. Use the HDFS, DS, put, and list commands to place and view the file on HDFS respectively. If you've tried out the MapReduce program on Cloudera, your programs would still be stored on HDFS as shown here. If not, then it's time for you to create and save them. Run the Hadoop job and submit the MapReduce task. Once the job is submitted, it runs the mapper followed by the reducer. Once the map task is completed 100%, the rest of the tasks start, and the status of the job. You can see that it is successfully completed. Check the output on HDFS using the command shown here. You can see how many files have been successfully executed. Finally, view the output and verify the output count. Note that mapper assigned the value 1 to every word indiscriminately. However, the reducer identifies the number of times a word is repeated and sums up the count. First, check for Spark context availability. This is a vital entry point to the Spark program model using PySpark APIs. Use the Spark context file to read the airport dataset. Find the total number of airports in the data file using the count method. View the first 10 records with the take method, passing the value 10 as an argument to it. Use the filter transformation to create an RDD, and the lambda function to select all the airports listed under NY as NY in the state code for New York. Check the total number of airports and use the collect method to display them. You can check the output to see that NY appears in several instances, even though the location is not based in New York. For example, Lanai Airport in Hawaii or Yuma International in Arizona. It's important to clean up this data. You can see that all airports based in New York have comma space NY listed in the address. So update the lambda condition accordingly, as shown here. Check the count again to view the data using the collect method. Verify if the data is cleaned up correctly. Let's now quickly recap what we have learned in the lesson. As Python is a data scientist's preferred choice of language, it's important to provide big data solutions that accommodates it. There are two primary components of Hadoop architecture: Hadoop Distributed File System, or HDFS, and MapReduce. Both Hadoop and Spark provide Python APIs to help data scientists use the big data platform. MapReduce has two functions: mapper and reducer. MapReduce carries out computations on data through disk I/O operations, while Apache Spark carries them out in memory. The main programming approach of Spark is RDD. Spark is almost 10 to 100 times faster than Hadoop MapReduce. There are mainly four components in Spark tools: Spark SQL, Spark Streaming, MLlib, and GraphX. Python integration with MapReduce and Spark is the last lesson of the Data Science with Python course. You can go through our simulation test papers and work on the project to help build